Today we are going to see how acids and bases they react with each other. So let's take an example. Let's take sodium hydroxide in a test tube. So we have taken sodium hydroxide solution in a test tube and then add a little bit of blue litmus or red litmus paper to it. Then what do we observe? When you add any red litmus paper, it turns into blue. Alright, so red turns to blue. Now you slowly keep on adding a little by little HCl solution to it and repeatedly test with red litmus paper. So it will turn to blue. After some time, some amount of HCl is already added to the sodium hydroxide. Then you will observe red remains red and blue also will remain blue. Then still when you keep on adding HCl to the NaOH solution, you try testing with blue, so blue will start turning red. So from this experiment, what can we observe? What can we conclude? That when you are adding acid to a base, they are neutralizing each other. Slowly the solution is turning neutral when red is remaining red and blue is remaining blue. There is no change in the indicator, which means the solution is neither acidic nor basic. So that's the point when we say that the solution is neutral. So the acid is neutralizing base or the base is also neutralizing acid. Alright, then after neutralization, when you still continue to add HCl, then the solution is turning out to be acidic. That's the reason why the blue is turning into red. So we can say that acids and bases, they react with each other or they neutralize each other. And what kind of reaction is taking place? Acid reacts with a base to give you salt and water. So if you take sodium hydroxide, that is NaOH, plus HCl, then we are going to get NaCl plus H2O. So we conclude that acids and bases react with each other to give us salt and water. Now the next type of reaction is reaction with metallic oxides. How do acids react with metallic oxides? Now when you have metallic oxides, let's say you have zinc oxide and you add HCl to it, you will get zinc chloride plus water. Now how do you prove that salt and water are getting formed? When you take let's take an example in which you take a small amount of copper oxide in a beaker and add dilute hydrochloric acid to it, and slowly you keep on mixing it. Then you will see a change in color of the solution. So solution from colorless to become greenish, bluish green, blue-green solution, like that, because copper oxide dissolves in hydrochloric acid to give you copper chloride, which is green in color. So that's why we can conclude that copper oxide plus HCl gives us copper chloride plus water. So we can say that salt and water are getting formed. Now do the bases react, do the non-metallic oxides react with acids? Now, one of the examples of non-metallic oxides is carbon dioxide, and we have already seen that it reacts with calcium hydroxide to give us a salt and water, right? So we know that calcium hydroxide is a base. Calcium hydroxide is a base, and always a base reacts with acid to give us salt and water. That's the reason why we can conclude that non-metallic oxides are acidic in nature. So, if acidic in nature, so they will not react with any acids. Now, these acids and bases, do they have something in common? Let's see. Let's take few solutions in this setup that you can see over here. So you can take a solution of glucose, then alcohol, then hydrochloric acid and sulfuric acid. You can fix two nails as it is shown in the figure on a cork, and place the cork in a 100 ml beaker. Connect the nails to two terminals of a battery, and there should be a bulb connected to that setup, so that when you switch on the battery or switch on the setup, then we can see whether the circuit is complete or not, whether the current is passing through the circuit or not. Now you can use any of these solutions in the beaker and try passing electricity through it. What are you going to observe? You will observe that in case of acids and bases, the bulb will glow, which means that the circuit is complete and the electricity flows through the solution as well as through the wires that we have connected. So how electricity is flowing through the solution? There must be something in the solution which conducts the electricity. Now what are these? These are the various ions which are present. So what are the ions present in the acid? When acidic solution is there, we have hydrogen ion in the solution, and you will have the counterpart, the metallic ion also. From the acid and the bases, they contain hydroxide ion, that is OH minus. Now due to the presence of these ions, the solution becomes a conductor of electricity, and hence it conducts electricity. So we can conclude that both acids and bases, they have ions. When they are put into a solution, or when the acids and bases are dissolved in water, they produce ions. Acid produces H plus ion, and bases produce OH minus ion, and when the ions move inside the solution in the presence of electric current, then they conduct the electric current. So they are conductors of electricity. In other words, these are also called as electrolytes. Alright, so these are also called as electrolytes because they conduct electricity. Now as we are talking about dissolving the acids and bases in water, what happens to them in water? Why do they generate ions? So for that, let's do an experiment over here as shown in the figure. We will take about 1 gram of solid NaCl in a clean and dry test tube and set up the apparatus like this as shown in the figure. Then we'll add some concentrated sulfuric acid to the test tube, and then we'll just put a cork over that, and through a delivery tube we'll pass the gas which is coming out onto a blue litmus paper. Now what gas is coming out? We have taken NaCl and we have added concentrated sulfuric acid to it. So what do we observe? The blue litmus paper turns into red. So what gas is produced? there is some acidic gas produced which is turning the blue litmus into red. Alright, so if you have a dry gas which is coming out, then if you pass the same blue litmus paper onto that gas, then it will not turn the blue litmus into red. But if you have a moist gas which is coming out, then it turns the blue litmus into red. So what is the gas which comes out over here? It's nothing but HCl. When you take sodium chloride and sulfuric acid, then HCl gas is produced. Now if you take a moist litmus paper, then only the blue litmus turns to red. If you take a dry litmus paper, it does not change the color. So we can say that when HCl comes in contact with moisture, it produces H3O plus Cl minus. Now this H3O plus is nothing but H plus when bonds with water. This H plus ion cannot remain alone, so it has to combine with water to remain as H3O plus, and all the acidic solutions, they contain this H3O plus ion, due to which they are acidic. So H3O plus ions are the characteristic ions present in the acids. Similarly, if you take a base like NaOH and you add water to it, then it splits into OH minus plus Na plus. Now OH minus is the ion which is responsible for the basic behavior or alkaline behavior of the substance NaOH. Now from this experiments and from the reactions, we can easily conclude that all the acids contain H plus ion and all the bases, they contain OH minus ions. Now when we know the ions present in the acids and bases, then how can we write the neutralization reaction? We have NaOH plus we have HCl, then we can say that OH and H plus, they go together, and Na and Cl, they join, so you get NaCl plus H2O. Alright, so this is how the neutralization reaction takes place. Now when we handle these acids and bases, mostly the acids, bases are not that much harmful, but acids are very harmful. So when we add water or acid, when we mix water and acid together, we should never add water to acid. We should always do the other way. We should take water and then slowly we should add the concentrated acid to dilute it or to prepare a solution. If you add water and you take water and add it to concentrated acid, this reaction is explosive and exothermic. A lot of heat energy comes out, so the glassware in which you have taken the acid might burst and the acid might splash into your face or onto your body. So it's very harmful. That's the reason why we always add acid to water, not the other way. So this is a must. You all must remember that acids are never used. Water is never added to acid. Acid is added to water slowly, so that the reaction takes place slowly. The exothermic reaction takes place slowly and it's not harmful or dangerous. Alright, so this is all about the reactions of acids and bases and how do they react with each other and how do they react with water. What are the ions produced in water when they are dissolved? So this is all about it. I hope this so far all the reactions and the characteristics of acids and bases are clear to you. Thank you.